functions unit, and we're going to be focusing on linear functions, and specifically today we're going to start with slope. So a function in general is just a relation between two values where every input x has exactly one output y. So that exactly one part is really important. Each x will only go with one y. Now, when two quantities, x and y, vary so that one is a constant multiple of the other, then the two quantities are proportional. So that's going to be one of our vocab words that you'll be hearing a lot. Proportional relationships will always pass through the origin of a graph at the point 0, 0. So remember, that's just the center of a graph where x is that horizontal axis and y is the vertical. 0, 0, the origin is right in the middle here. Proportional relationships can be represented with the equation y equals mx, where m is called the slope. So you'll see equations in this form, and the m is what we're going to be solving for. That slope is going to be different in each type of the equation that we're going to be seeing. Slope can also represent the rate of change of a proportional relationship between two quantities. So you could be talking about the rate of change of the speed of something over time, or how much money is accruing after a certain number of days. These are going to be some examples that we'll see with this type of relationship. This is going to be an important formula that we're going to come back to problem after problem. M is the same as slope, like we mentioned up here, and slope can be calculated in a few different ways. It's the change in y over the change in x, or divided by the change in x. So the change in y, remember the y-axis is the vertical axis, so your vertical change is going to go with the change in y. Horizontal axis is x, so that's going to be your change in x. So similar terminology here, but just different way of saying it. And then the other way that we're going to hear it most commonly is rise over run. Think about if you're rising, you go up, the sun rises each morning, it comes up into the sky. If you're running, you're moving horizontally. If you are running on the flat ground, you're running horizontally. You can't run up a wall. None of us are superheroes, unfortunately. But that's a good way to remember. Rise will go up or down, and run will go side to side. Now, as we get into different sorts of functions in the future, the ones that we're going to be focusing on in Math 7 are going to be linear functions. Now, you can see functions in all sorts of representations, so we'll be seeing them just as ordered pairs, in tables, on graphs, or we'll just talk about them verbally, like giving the description. So, like I said, we'll be focusing on those linear equations. Notice the word linear starts with the word line. So linear functions make a graph that is a straight line. So when we graph these on a coordinate plane, it's going to look like a straight line. So you would have your x and y axis, and then the actual graph of this function could look something like this, where this green line would show that's your graph of this straight line that we're talking about here. So a set of ordered pairs, remember an ordered pair is written as x comma y. It's something really important that we'll be seeing over and over again. They can be written as a table. So you could see these points listed in a table like we have below here. So when it says the x column and then the y column, each of these points, or each of these numbers go with each other. So this is the x, 4, and 2 is your y. So this would be a point that you would plot on the graph if you were given this table. 6 and 3, you would see 6, 3, that would be the point you're plotting on the table. So for this example specifically, these values are part of a proportional relationship. This can be shown by using the ratio of y to x. Ratio means we're going to do a fraction, so we're dividing y over x. So to set that up, we're going to take our y value, 2, and we plug it in, and then we put 4 underneath, so we have 2 over 4. So that's where we're getting these values from, 2 divided by 4. And if you simplify that, you're going to get 1/2. Now we check the other ones, the other y and x values that we have. So 3, we're putting right here, over, we have 6 as our second x value here, 3 over 6. Now 3 over 6 also simplifies to 1/2. So since both of these ratios of y over x are equal to 1/2, then this is going to be a proportional relationship because their y over x values are the same each time that we check the points. If you go through and check the points of all of a table and even just one of them doesn't match the ratio, then it will not be a proportional relationship and we won't be able to find the slope. So since each of these values are proportional, it's because their ratio of y to x was equal to 1/2 or 0.5. Now let's get into some practice of deciding whether things are proportional using that same method. So in this first example, we have the table x and y, where we have points 1, 3, and 3, 9. So remember to take your ratio of y over x for both sets of points here. So y over x in this first one is going to be 3 over 1. My y was 3 and my x was 1. 3 over 1 simplifies to 3. And then we'll check the next point. So our next point is 3, 9. So y over x again is going to be 9 over 3. And 9 divided by 3 is 3. So since both of these ratios are equal to each other, and those are the only points we have in the table, we can say that this relation is proportional. So go ahead and check the next 3 on your own, and then check your answers with the solutions that I put on the screen. All right, hopefully you pause the video and try these on your own. Here's your solution set. So in this first one, we have y over x, we have 4 over 7, and then we have the second one as 5 over 8. Now if you put these in the calculator, you're going to get about 0.5 and 0.6 to round it. So those are not equal ratios, so this is not going to be a proportional relation. In the next one, we have 4 over 16, and that simplifies to 1/4. And then our second y over x would be 5 over 20, which also simplifies to 1/4. So these two are equal, so we do have a proportional relation here. In this last one, we have negative 15 over negative 3. That equals 5. And then we have 5 over 1, which also equals 5. So this set of ordered pairs is proportional as well. So each of those ratios are equal there. Now, the reason that we check to see if something is proportional is because if a relationship is proportional, we can use this form, y equals mx, the one we saw earlier, where the slope m is the ratio of y to x. That means that if this is proportional, we can say that m is the same as y over x here. So we say in this one, this is the example that we had earlier, we saw that 2 over 4 was equal to 1/2, and then 3 over 6 was also equal to 1/2. So that's going to mean that our slope is 1/2, as we see here. So all we have to do is take this formula, y equals mx, and where it has an m, we're just going to plug in the value that we have for m. So the y equals comes down, our m is 1/2, and then x comes down as well. And then this becomes the general rule for this table of values here. So that would mean that any x value that you plug in here, you'll get a y value that comes out of here that's going to be on the graph of this line. So I know that's kind of a lot to think about, and until we start seeing it on the graph, it might not make too much sense, but we are going to just practice kind of working with these function rules to practice finding the slope and then plugging in to find different points that we could find on the line. So in this next set of problems, we're going to be checking these tables first to see if they're proportional. But remember, we have to find that ratio of y to x still. And if they are proportional, then we can use that ratio as the slope, or that m value, and then write the equation in the form y equals mx. So taking a look at this first one, we have x and y is 3, 12. So since our y is 12 and our x is 3, we can say 12 over 3 is our first y over x. So 12 divided by 3 is 4. We'll keep going down, check all the values, make sure this whole relation is proportional. We have 16 over 4, that's equal to 4. And we have 20 divided by 5, which is also equal to 4. So yes, this is going to be proportional because we just checked to see that each of these values, when you do y over x, are equal to 4. Now, another way you can see this is to say, okay, well, here's x. What do I have to do to each of my x's to get to y? Well, to get from 3 to 12, we can multiply by 4. To get from 4 to 16, we can multiply by 4. To get from 5 to 20, we can multiply by 4. So for each of these x values, we can get y by multiplying x by 4. So since this was proportional and the ratio of y to x was 4, our slope here is going to be 4. That means that's our m, as we said slope is equal to m. So using this form, y equals mx, we can say y equals 4x. Now, what did we just see here? Every time we have an x value and we multiply it by 4, we can get to y. This formula says that every time you have y, it's the same as multiplying 4 times x. That's the same thing we saw up in this table. We're just writing this general rule for it for any x and y value that we want to plug in here. Go ahead and try this next one on your own, so pause the video if you want to try it yourself. If you're still a little shaky, just keep watching and we'll explain how to do that. So now it's time to check your work or to just watch for more guidance on this. So we have these sets of points here. You could write them all out in this XY form if you want to. To get the first thing you want to do is figure out if it's proportional. So test all of your y and x values in their ratio. So y divided by x, negative 18 divided by negative 9 is our first set, and that's positive 2. In our next one, we have negative 24 divided by negative 12, that's 2. Negative 28 divided by negative 14, also 2. So yes, this is proportional. Our slope is 2, and that means that in a y equals mx form, it's y equals 2x for this equation. Now, if you go back into your table, what do you need to do to x to get to y? You have negative 9. If you multiply that by 2, you'll get negative 18. Negative 12 times 2 is equal to negative 24. Negative 14 times 2 is equal to negative 28. So every time you have an x, multiply it by 2, and that will equal your y. It's just kind of that other way of seeing that there. There's 2 others on your next page of notes, so go ahead and pause the video and try those 2 on your own. All right, now that you've tried those on your own, here's our quick solution. We have 4 over 12 as our first y over x, and that's 1/3. 5 over 15 is also 1/3, so yes, these are proportional. The slope is 1/3, and yes, you can have fractions, that's fine. And you will have y equals 1/3 x as your equation. Now, if you multiply 12 times 1/3, remember multiplying by a fraction like that is just like dividing by 3. 12 divided by 3 is 4, so that's going to work. And same goes for 15 times 1/3, we get 5. So our rule of 1/3 times x will always get us our y value for this relationship. In our final example here, we have negative 15 over 3 and 5 over 1 as our y over x values. These are both equal to 5. These are proportional because they both have the same y over x fraction, and that means our slope is 5. So y equals 5x is our equation. If we multiply each of our x's by 5, we should get our y values, and that is true for both of these here. So hopefully you're starting to see kind of those connections of why the y equals mx form works for each of these tables when we have proportional relationships. Now the last thing that we want to look at for today's video is if you're given one of these rules in the y equals mx form, and then given a list of points, we want to be able to figure out which one of these points are actually going to be in the graph of this line. So the first thing is you want to take the equation that they give you and evaluate it using the point x comma y that is given. You'll simplify the equation, and if both sides are equal, then the point is on the line. If they're not equal, it won't be on the line. So just to evaluate this first equation, we have y equals 3x. Remember, our points are written in x comma y. So y is 8, so I'm just taking y here and replacing it with an 8. 3 comes down, that was part of the original equation. And remember, if we have 3x, that's like 3 times x, so I'm going to do times, and then negative 4 is my x value here. Now I just have to simplify, so I have 8 on the left side equals 3 times negative 4 is negative 12. So unfortunately, these values are not equal. So this point will not be on the line of the graph y equals 3x. But we can keep testing the points throughout. So again, we use the process y equals 3x. So our y here is 9. So I say 9 equals 3 times our x value, which is 3. 9 equals 3 times 3, which is 9. That is true. So this point, 3 comma 9, would be on our graph of y equals 3x. Same idea follows in the next one. We have 18 as our y value equals 3 times our x value, which is 6. 18 equals 3 times 6 is 18. 18 equals 18, so that's true. That means that this point will also be on our line of y equals 3x. Testing our last point, we have 3 as our y value. 3 is in the equation, and we're multiplying our x is -1. 3 equals -3 is not a true statement, so this will not be a point on our line. So only these 2 points would be on the actual line of this graph y equals 3x if we put it on a coordinate grid. So if you think you understand, go ahead and pause the video and try these last 2 examples on your own, circling the points that are on the line and putting an X on the ones that are not. Okay, hopefully you took a minute to try those on your own. Remember, all you have to do is plug in your X and Y value for the rule. So in this next set, we're using this rule, y equals 2x. So just multiplying every x by 2 and setting it equal to y. So in this case, -8 does equal -8, so this is a point on the line. Here we have 14 equals 2 times 7, which is 14 equals 14, and that's true. So that's another point on the line. -18 needs to equal 2 times -9. -18 equals -18 is true. So that's another point on our line. And in our last example, we have -8 equals 2 times 16, and -8 does not equal 32. So this would not be a point on our line. So just those first 3 are examples here. In our last equation given, we have y equals 1/2 x. So you're just going to take half of each x value and hope that you get y. So if I have y is 14 and I do half of 7, 14 is not equal to 3.5. So this is not a point on our line. We have 3 equals 1/2 times 6. 3 equals half of 6, which is 3. That's true. So 6/3 is a point on our line. We have 8 equals 1/2 times our x, which is -4. And 8 equals -2 is not true. So this is not a point on our line. And in our last one, we have -7 equals 1/2 times -14. So -7 equals -7. That's true. And this is another point on our line. So you're always able to plug in your x value to your rule to get y, and that's going to help you find values that you can plot on your graph and to test values if you're given a list like this to determine what is on the graph of the line. Thank you for watching.